Hello and welcome to DCC Model Railway Signalling. In this video we're going to pick up from where we left off at the end of video 4, and we're going to configure our layout to provide automation of the track sections, so trains will automatically get passed on our schematic diagram from one track section to another when a signal is passed. And we're also going to configure the signals to be sort of semi-automated, in that they'll be overridden to display a danger aspect when the track sections ahead are occupied. So without further ado, we'll open the application up and we'll load up the layout from the end of video 4. So I'm just going to change this into edit mode by Control M. And what we need to do for each of the signals, we need to think about the train movements that it is signaling. So for example, signal 5, when signal 5 is passed, it's going to be passing a train from track section 5 to track section 2. So that's achieved via the signal configuration, and if you go to the automation tab, it's this area here which is track occupancy changes. So this is straightforward. There's only one route, one movement, so that will go from track section 5 to track section 2, and I'm just going to OK that. Signal 1 is slightly more complicated. If I go to the automation here, it's going to be passing it from track section 2, but if the route's set for the main, which is into platform 2, that's going to be track section 4, but then the left-hand divergent route is going to be into platform 1, which is track section 3. So I can apply that. Okay. Signal 3, really straightforward, only one possible route, out from track section 4 to track section 2. Signal 2, again, this is another signal with two routes, and it's always going to be passing trains out from section 3, but the main route is out to the rest of the world, so that will be track section 2, and the right hand 1 route is back into the siding, which is track section 1. And then finally signal 4, and that's again really straightforward, from track section 1 to track section 3. And that's configuration completed, and we can actually test it up out without linking it into our layout, by putting the application into run mode. And what we can do is we can simulate the sort of GPIO track sensor events by clicking on the base of the signal. So if I set a track section to occupied there and clear a route into platform 2 by setting the signal off. So if I click on the base of that signal, that is going to simulate a signal passed event. Click on that and you'll see that it has passed the train to the next section. Now if I click on the base of signal 1, and that has passed it into there. Signal 3 will also be passed by the train as the train moves into platform 2, but if we click that, it has no effect, because the logic behind the scenes does its best to actually sort of work out what move is actually going on. If we want to now just test the movement out again, so we'll set that to red and we'll set that to clear. So now I can click on signal 3, signal 1, signal 5, and that has passed the train out to the rest of the world. We'll set that back to danger and we'll just check the route back into platform 1. Set that to clear, signal 5, signal 1, and then signal 2, which has no effect. Finally, we'll just check the move into the siding. So we'll just change the points there, and we'll set the subsidiary signal to clear, signal 2, signal 4, and it's in the siding. Set that back to danger and set signal 4 off, signal 4, signal 2, and it's now back into platform 1. So now we've got sort of full confidence that our configuration is correct. So we can now, if you like, wire it into the real track sensor on the layout. And for wiring the sensors in, refer to the user guides that come with the system, or they're available for download from dccmodelrailwaysignalling.co.uk. But as far as configuration is concerned, that's via settings and then sensors. And this gives us a list of all the GPIO ports that are available on the Raspberry Pi for the software to use. And the GPIO port stands for General Purpose Input and Output Port. But for our application, we're using those as inputs, and we're mapping those to track sensor objects. So if I create some track sensors, and I'm going to keep it nice and simple: track sensor 1, track sensor 2, track sensor 3, track sensor 4, and finally track sensor 5. So what that means is when a GPIO 8 port on the Raspberry Pi is triggered via a sort of momentarily sort of closed event, what that will do, that will raise an event for track sensor 5. So now we've created the track sensors, we can now use those within our layout configuration. So we'll go back to edit mode, Control M, and we'll assign them to the signals, and that's again via the automation tab. So automation tab, so for signal 5, the signal path sensor, we're going to use track sensor 5 that we've created. Okay. Similarly for signal 1, we're going to use track sensor 1. Signal 3 is going to be track sensor 3. Signal 2 is going to be track sensor 2. And finally, signal 4 is going to be track sensor 4. Now, what will happen is if an external track sensor triggers GPIO port 4, that's going to raise an event for track sensor 1, which we have mapped to signal 1. So that will then generate a signal passed event for signal 1. And that's it. That's all you need to do to configure it to connect into your layout. There's one final thing we're going to do now that we've got the track occupancy working in terms of trains being passed from one to the other. We're now going to add a level of automation to automate the signals changing red behind the train. And to do that, it's really, really easy because we select each signal in turn. And so for signal 3 on the automation tab, we just want to override the signal to on if the sections ahead are occupied. So we're just going to click that, select that, and what we want to do as well, we probably don't want to be signal a movement at all if section 2 or section 5 is occupied. So we'll add track section 5 in there as well, and we'll click OK on that. Signal 2 for the automation, again for the main route, track section 2, yeah, we really don't want the signal to be at green if track section 5 is occupied, so we'll add that in there, and we'll override the signal to on if the section ahead are occupied, and we're just going to OK that. Signal 1, this is more straightforward. All we need to do is we need to just select that and OK. We're not going to bother with the subsidiary signal there because, again, if that section is occupied, it's absolutely valid for that signal to be cleared. That might be a sort of light engine joining the train, etc. Similarly, we don't need to do anything with signal 5 because that is always at caution as it's a fixed distance. Now, if we go back to run mode and we put a train in and feed that in. We're going to feed it into platform 2, and we'll clear that signal. And you can see that not only is signal 3 locked because that track section is occupied, and we covered that in video 4, it's also got red text in it, and that means it's overridden. So even if it was clear, it would be overridden to danger anyway. So we'll simulate the movement back into platform 2. So we'll click that, and click that. And as you can see, although we haven't set that signal back to danger, because platform 2 is now occupied by a train, that signal has been overridden to red. Let's set that back to danger, and now we'll do a move the other way, and click on that, and you can see here signal 3 is overridden to red. And that means that no other train can depart. And that gives you a level of semi-automation. If you want to be an active signal man or woman, then you can just disable automation. And here we go. You can see now signal 3 is absolutely under your control, apart from the interlocking. But if I put the automation back on again, you can see it's overridden. So it's entirely up to you whether you want to be an active signal man or woman, or whether you want to just sit there and watch the trains go by. And in later videos, we'll do a few more complicated automation examples that show the real sort of power of the application. But that's all for now. So thank you for watching.